Welcome to today's lesson. We are going to look at spring balance, and we start by giving the steps and procedures on how to make a simple spring balance apparatus. We need a strength or a string, firm cardboard cylinder or cuboid, strong helical spring with a pointer attached, wooden strip with a hook, wooden rod, 100-gram masses, strip of graph paper, small wooden blocks or stones. We proceed as follows. 1. We prepare the cuboid so that there is a spring with a pointer and a wooden strip with a hook as shown here. And this one you are doing it using your free hand. So we have the strip of graph paper here, we have the helical spring here, we have the pointer, and of course we have our hook that is connected here, and a wooden block where we have attached our spiral, our helical spring. Then after that, the second step, you are supposed to fix the graph paper on one side. The graph paper will help us to put the scale. Then the spring balance is now ready for calibration. This is putting now the values so that you can be able to graduate your spring balance. So with no mass on the hook, that pointer should be marked 0. Then after that, you're supposed to suspend 100 gram. If you convert this into weight, that is, you divide by 1,000 and then you multiply by 10, you will get that 100 gram is equivalent to 1 Newton. So when you put the first 100 gram, then the pointer should go to 1 Newton, and therefore you mark that as 1 Newton. You continue adding the masses in steps of 100. So that now after 1 Newton, you go to 2 Newton to 3 Newton until you are satisfied with the number of the points. Then after that, you have your spring balance. Spring balance is used to measure the weight of a substance. Then from there, we move to problems on Hooke's law. In this part, we are going to do a lot of worked examples. We start with the first one. We have two identical springs, X and Y, are connected in series, and a stretching force of 10 Newton is applied. Given that the spring constant of each is 64 Newton per meter, determine the resulting extension. Remember, these are identical. So to get the combined spring constant, we've said that Ks is K over N. So it will be 64 Newton per meter divided by 2, you get 32 Newton per meter. Now to get the total extension, we can use this formula of Hooke's law. F is equals to Ke. Now our K is our Ks, that is the combined for the series arrangement. Our force is given as 10 Newton. So 10 Newton is equals to 32 multiplied by E. So our E will be 10 divided by 32, which will give us 0.312 meters. That will be the total extension. We move to another example. The figure below shows two identical springs arranged in parallel. Determine the total extension produced by the arrangement, given that a single spring extends by 2 cm when supporting a 20 Newton weight. This is our diagram. So these values that are given will help us to get the spring constant. We are given the extension, we are given the force. Therefore, our K will be 20 over 0.02. That is our extension. We have divided by 100 to make it in meters. Now this value, which is 1,000, gives us the spring constant of one spring. But now we have the two in parallel. So we get the total combination. We say that when you have them in parallel, the spring constant increases. And therefore it becomes Nk, where N is the number of spring constants, or the springs that are connected in parallel. So our Kp will be 2 multiplied by 1,000, you get 2,000. Therefore, our F, which is Kpe, will be given by 120, that is our force here, is equals to 2,000 multiplied by our extension. So our extension will be, you divide by 2,000 because you are multiplying here. So it will be 120 divided by 2000, you get 0.06 meters. That will be now the total extension. We move to another example. Two non-identical springs A and B are connected in series, and the stretching force of 10 Newton is applied. Given that A has a spring constant of 64 Newton per meter and B has a spring constant of 100 Newton per meter, determine the resulting extension. So here, because they are non-identical, we treat each spring separately. So we start with the first one. F is equals to KE. From here, we can be able to get the extension. So our E1 will be 10, which is our Newton, that is force, divided by the spring constant, which is 64. So you get 0.156 meters. We move to the second spring B. Our force remains as 10, but now the spring constant has changed into 100. That is for the spring B. You divide 10 divided by 100, you get that the extension is 0.1. Now to get the total extension, you are supposed to add the 2, E1 plus E2, and that will give you 0.156 plus 0.1, that will give you 0.256 meters. Note that because they are in series and they are not identical, we have treated them separately, and then you add their extension. We move to another example. We have that a force of 8 Newton stretches a certain spring by this. How much work is done in stretching this spring by 10? So first of all, we need to get the K using the first value. We have your K is F over E. You are given F as 8 and the extension as 5 centimeter. This convert it into meters, you get 0.05. So that now you get your K as 160 Newton per meter. So work done is given by a half KE squared. So you substitute your values. A half times K, that is 160 times 0.1 times 0.1. So when you multiply, you get that the work done is 0.8 Newton meter or joules. We move to another example. The figure below shows the arrangement of 3 identical springs supporting a mass of 2.0 kg. This is our arrangement. The first 2 are in parallel, then the other one is connected in series to them. But we are given that the spring constant is for each is 500 Newton per meter. Remember now, in this case, they are identical. So we proceed as follows. We have our K, we have our F, which is 10 Newton. So for the 2 parallel springs, we can be able to get the combined spring constant. And this one is given by NK. So we have K for one spring. So the total spring constant for the first 2, which are in parallel, will be 2 times 500. You get 1000 Newton per meter. Now to get the extension, that is E1 for the first 2, it will be 20 Newton divided by 1000, you get 0.02 meters. For the one spring, that this one, you consider the spring constant for one, which is 500. So you take 20 Newton, that is our mass, our weight, divided by 500, you get 0.04. Now the total extension will be the sum for the 2, E1 plus E2, and that will give you 0.06 meters. From there we have the assignment. Again, most of these assignments are for calculation. So the answers are provided on the notes below the video. Make sure that you evaluate yourself, practice, and make sure that you get the correct answers. Thank you, and let us meet in our end of topic exam.